Welcome to my house. Welcome to the Structure Talk podcast, a production of Structure Tech Home Inspections. My name is Reuben Saltzman. I'm your host, alongside building science geek Tessa Murry. We help home inspectors up their game through education, and we help homeowners to be better stewards of their houses. We've been keeping it real on this podcast since 2019, and we are also the #1 home inspection podcast in the world, according to my mom. Welcome back to the show. This is the Structure Talk podcast. Tessa, always great to see you. How you doing today?
Good to see you. Hey, I'm doing well. How are you doing?
Can't complain. Had a very relaxing Thanksgiving with the family. Got the Christmas decorations up. Got together with everybody. It was great. We've got a guest on, so we're going to keep the small talk short. But before we introduce Jake, I want to give a shout out to our show sponsors, IEB, Inspector Empire Builder. I have been a member with them for many years now. It's so funny, Tess. Here's one where we were doing a group interview. We were hiring a bunch of new home inspectors. Well, a couple, I shouldn't say a bunch. And I've got this screening process that I was using to get through all these applications we got on Indeed. We had like over 200 people apply. And I had this cool little trick to screen through them. And I thought, I'm so genius. I figured this out. And I'm so glad I came up with this idea. But then I was going through my notes on new hires, and there were some notes I had taken from an IEB call back in 2019. And that's actually where I learned how to screen through all these interviews. And it's like, wait, this wasn't even my idea. This is something I learned through one of these IEB meetings many, many years ago. So
and it's just become you now.
Exactly.
It's fully integrated.
I have maybe forgotten as much as I have learned through them. That's how much I've learned. So
Which is saying a lot for you, Reuben, because you don't forget a lot.
I have a good memory, but it's not perfect. So we will have a link to Inspector Empire Builder in the show notes. Love those guys. All right. With no further ado, I want to introduce Jake McAlpine. He is with the Energy Conservatory. And Tessa, you've known him for a long time. You trained underneath him back when you were doing weatherization. You went through you went to school with him even before that. Back when you were going to the U. Well, let me turn it over to you. You'll do a better job of introducing. Go ahead.
Well, let's let Jake introduce himself. Jake, we're so happy to have you on today. Jake graduated from the University of Minnesota with a building science degree as well, like I did. He went through a little bit before I did. And he is just a wealth of knowledge. And I think what you're doing today in the company you're working for is so interesting and so fascinating. And you recently invited me out and Pat Hillman and some other people at the U of M to kind of look at the facility and talk about the things that you're doing now. And so I just thought it'd be a great idea to have you on our podcast today and to kind of hear a little bit more about your background, what you do, how you've got to where you are today, and then we'll dive in from there. So Jake, thanks for coming on the show. And would you start off just by telling us a little bit about your work history?
Yeah. First of all, thanks for having me. You guys are awesome. I started out actually, I worked in a recording studio, did audio at a recording studio. I took that piece of advice in high school to, do what you love. And at that time, I really liked music. So I'm like, okay, well, I guess I'm going to work in music. And I wasn't very good at playing music, but I like the technical side of things. So I did that for a while. And then I got out into the real world and I was like, oh, wait, I need to make enough money to buy a house someday. That's not going to work in the music industry. So I really quickly shifted gears in my early 20s and wanted to do something more meaningful, basically, is how I came to it. And I was on the clock at this recording studio going, I can only make so many more Subway commercials before I feel like I'm actually polluting like people's minds in the world. So I called my wife and I'm like, I don't know if I can do this. And she's like, you just started this. Okay, I guess let's not do this then. And I was like, I'm gonna look for classes at the U of M. And she's like, okay, great, I'll look too. And I called her up a few hours later, and we had both picked the same degree out of the whatever, dozens
Oh
or
my goodness.
hundreds,
Wow.
hundreds
Which is
of
crazy too, because
Right.
it's kind of hard to find that degree at the U of M. It's buried under College of Food, Agricultural, Natural
Yeah.
Resource Sciences, and like bioproducts, biosystems engineering. How did you both find that? That's crazy.
Yeah. So anyway, the degree that Tessa and I both took was a residential building science and technology degree. It's gone through a few iterations since then. But I mean, I just felt really lucky to find that. And Pat Human and Mary Lou Chappell, the other people that were involved as educators, were really good. They came from, like, Mary Lou was a builder, so she came from that side of it. Pat had been in academics and just knew build. I mean, Pat's got a really deep knowledge. And so it was great. You got to spend 3 years just underneath masters like that and learning a lot of different things about buildings, really getting challenged, and then jumping out in the world and started auditing through the Weatherization Assistance Program, which is a phenomenal program that's been doing energy audits since, I think they literally started in the late 70s with the oil crisis. And the first time that building science was really coming into its own, when people were trying to save energy, when fuel costs shot up, weatherization was right there, kind of boots on the ground from day one. So that was a fantastic program to get involved with right out of the gate, because you had 40 years worth of knowledge, essentially, or 30 years worth of knowledge, and all those original people were still largely around. So you could hear it kind of directly from the people who were like, "Oh yeah, we didn't know what a stack effect was, really. We didn't realize that moisture could move to a place we didn't want it in a building and wreak havoc. Yeah. We didn't realize we could backdraft appliances when we thought we were doing good stuff like air sealing, that it had a negative side, and that this really is a balance." So was in weatherization out in the field for a few years, did some management stuff there, did some research stuff at the Sustainable Resources Center in Minneapolis. That's where I worked with Tessa. And then I really liked the program. I also really liked some of the, I thought some of the tests and things could be done better. And so there was an opportunity to go to the state level and work on policy, which I really enjoyed. Kind of broadened my perspective about, how programs work at a larger level. Rebates, solar, got really exposed to a lot of different stuff there. But ultimately, I really like the field, being in the field and having my hands on things. So about 3 years ago, an opportunity came up at the Energy Conservatory, and I jumped, and it's been fantastic.
So tell us, Jake, for our listeners that maybe aren't from Minnesota or aren't from this world of energy efficiency and weatherization, what the Energy Conservatory is. Who is this company? What do they do? What are they known for?
The Energy Conservatory is probably most known for producing the Minneapolis blower door system. So if someone needs to...
Real quick, for anybody who didn't hear it, I know what you said, but it was quick. You said the Minneapolis blower door. Okay, got it.
Yeah, and it's anyone who needs to get the leakage measured of a building's envelope. This is the device that does it. And also now with code compliance, duct leakage. Not now, but for quite a while, duct leakage has been also another thing that people measure. We also make something called the Minneapolis Duct Blaster that does the leakage measuring of a duct system as well. So those are kind of the main two pieces of equipment that we manufacture. And yeah, it's a really cool company. It was started here in Minneapolis in the late 80s by a guy named Gary Nelson. Gary's just a really curious, smart guy. Still is working today in his 70s. Certainly doesn't need to, but really is passionate about it and kind of mission driven, and likes solving problems and likes moving this idea of energy efficiency forward. So we're really lucky to still have Gary around and kind of still providing us with vision. And the company, we make the equipment that people use to measure, and then we get called in a lot to help solve tough situations. Gary and others work a lot with the standards bodies that help kind of define how tests are done and where they're done. And it's just, it's a really kind of fun place to be involved with if you like energy efficiency.
So when you get called in to solve stuff, who is calling you in? I mean, are these homeowners? Are these contractors? Are they government agencies? Like, who are you working for?
It's all the above. I mean, when people call us, they're really looking for an expert to weigh in on something. So they're not hiring us per se to come out and solve their problems. There's a lot of people out in the world that are technicians that are investigating buildings, trying to figure out what's going on. We get called on the weird stuff. Is this right, or is this possible? Those sort of just really fun scenarios. But yeah, it's everybody. I mean, we can get homeowners, we can get states that'll call us and say, hey, we're trying to run a utility rebate program. Are we really doing this right? Buildings are very different across the country and across the world. What's conditioned space? Where's the air barrier actually, and where do you think it was, and where is it actually? How is it performing? Things like that, where you really have to kind of dig in to each specific building to get the right answer.
And correct me if I'm wrong, but Gary Nelson, who started the Energy Conservatory decades ago, he actually invented the blower door, right?
He's kind of the Henry Ford. That's the way I've heard people say of, kind of the Henry Ford of the blower door. Cars were around before Henry Ford was, but he figured out how to make them at a scale and a cost that allowed them to be accessible to many other people. So
okay,
there's, the first research on blower doors. He showed me some really cool old, articles and notes that he had when he was going through college in the 70s. The first tests were done in the 60s, but they were research projects, government funded projects to say, how leaky is this building? And the setup for it it'd be ridiculous, to ours today, what it took to depressurize or pressurize a building and determine where the leaks were. It was a very big process. And so Gary saw that sort of stuff. There's a gentleman named Gautam Dutt who Gary knows well, who was in National Geographics in the mid 70s. And they show him doing a blower door test with a very early version of an infrared camera. I mean, stuff that we're doing now that's tried and true techniques for figuring out how to diagnose building issues, was starting to get institutionalized and figured out in the late 70s. And Gary was interested in it. So he built his own blower door. And then a friend or somebody asked him, hey, can you make me one of those? And so he made one in his garage. And then someone else asked him, and he kind of backed into it and started making these blower doors and figured out how to get them, smaller and lighter, so that they could. I mean, I remember some of the first advertisements I've seen they have. It said the tagline is like, portable, fits within a car. Like just the idea that you could get all the equipment into a car and get it to a house was a thing back then.
Yeah.
So yeah, Gary really moved it forward.
So yeah, and if you are in this industry and you live in Minneapolis, you've probably run into Gary or met Gary somewhere. And he's not only is he brilliant, he's an inventor. Like you said, he's a problem solver and inventor, but he's also one of the most humble people you'll ever meet.
Yes. Yeah.
And this business in this blower door, the Minneapolis blower door system is kind of, there's maybe another, like two competitors on the market, one competitor on the market, but yeah. What would you say? I mean, basically, if you're out there doing blower doors, you're probably between Minneapolis blower door or one or two of these other companies out there.
Yeah, I think back, in the 80s, I think there was 4 or 5, and now there's about 2 worldwide, maybe a third. So yeah, it's a small kind of niche market for making these really advanced fans that are using orifice equations to there's a known hole with these rings that we put onto the fans and sensors within them that are measuring pressure, which we can use then to figure out air in is equal to air out when you're doing these tests. So if we can pressurize a building or depressurize it and draw all the air through the fan, we can measure the leaks of the building. So it's kind of a way of summing up. Instead of trying to find each little leak in a house, we're pressurizing it or depressurizing it and forcing all the leaks in one direction and pulling them through the fan. And as it moves through the fan, we get to measure a pressure, and then we can equate that to a flow. So it's a niche thing, for sure.
It's a niche thing, but it's going to be required everywhere. I mean, as part of the building code, to be able to measure the air leakage of new construction,
Well, it already
builders
is,
are
isn't
required
it?
to do it.
Well,
Yeah,
new construction, you have to do it. It's been that
you
way
do.
for
In
what?
Minnesota.
Since
3.
2018, maybe?
Oh,
I mean, it really depends state by state. There are some states that are still kind of running an older code, where it's not. Well, it might be mandated, but it has a very, very high threshold. But yeah, once you move to the more current, the last 2 versions of the code, it's a big change. It's saying, yes, we need to have this measured. And in some states, they're starting to lower and bring the threshold down.
by threshold, you mean like the air leakage allowable for that structure, making that number tighter.
Yes, it's a code minimum that you have to pass. This is or a kind of a code maximum, I guess, another way to say it. Like the building can only leak up to a certain amount. Over that, it's too leaky. We need to do some air sealing type of stuff. So
well, here in Minnesota, is it 3 air changes per hour still, Jake?
Correct. Yep, it's 3 air changes per hour. And it kind of ranges. I mean, that's a pretty common threshold. There are some southern states that'll have 5. I think a few, or 1 or 2 might have 7. And I've heard of, I think, one state in the Northeast that's moving to 2.5, possibly, or 2. And then any jurisdiction, I think, can also make it tighter too. So some states will adopt it and change it a little bit. I think the big thing that's changing that I've heard more about is that in some of the newer codes, we're moving beyond just a residential building and testing like commercial, starting to test some bigger buildings. And I mean, that's an untapped area where tests haven't been done nearly as much as they have been on the residential side. So I think the residential
it's harder to test a big commercial building, isn't it? I mean, how many fans do you need to depressurize a high rise?
As Gary says, it depends.
I knew it.
It depends.
That's where you get it, Tess.
It is. Sorry.
I think one of the cool things that doing this sort of work has shown me, though, is that we can build really amazing buildings. I think, Tessa, I might have told you the story where it was 2 summers ago. I was invited by a local company here that was working with a builder on an 86-unit, 4-story apartment building. Pretty common. Wasn't cutting edge. You drove by it and it looked like any other 4-story L-shaped building. It's being put up in any urban area. But it was done to a very high passive house standard for this apartment building. And we needed 1 single fan to test this 84, 86 unit building. And the total leakage of this building was a few hundred CFM more than my 1951 house 5 miles away.
Wow.
Like I thought there was something wrong. I was like, how is this? This is a huge building. But with attention to detail and a really good design that said, hey, let's, instead of having a heating unit and a dryer in every single unit that has 2 holes that we have to, seal right, that have dampers on them, what if we centralized this and centralized the ventilation, and all the dryers went through a centralized unit, so they had one larger penetration that they could seal really well. And they just had a great design for this building. They did testing throughout the build process. And at the end of it, they had this, I mean, to me, that was the future. It was like, if we can build an apartment building as tight as we're building a house, or it's leaking as much as a house, a tiny house would, we could do some pretty incredible things. So
awesome.
I like the code does a great job of kind of all boats rising with the tide type of thing. But I think what people are learning is these great techniques that some people can just take and run with and make some really great buildings. So,
yeah. Well, I was going to say, building an airtight house is the goal, and that's the direction that, the building code and the industry is going. And part of building science is just understanding that when you change one thing, you impact another, and understanding those potential unintended consequences.
Yeah.
And everything is related to everything in the house. So you make the building envelope more airtight, and that impacts, your heating cooling loads, and it impacts how your HVAC system works and your ductwork sizing and all these things, and pressures in the house and air quality and the need for, mechanical ventilation. And so what I think is really interesting on the most recent tour that I had with you at the Energy Conservatory was, you started out initially kind of creating these like diagnostic testing tools for buildings of just how to find out how leaky they are. And, when you pair it with an IR camera, you can find those leaks and you can see them. Great. Okay. Then you create this equipment that can also measure like duct leakage. Oh, great. We need that too. How can we make our ducts more efficient? And now it's like, the Energy Conservatory, not only are you, creating this equipment that's needed, but you're also seeing the gaps and the holes in the industry as it evolves. And it feels like because you're a bunch of crazy engineering inventors that are so down to earth and cool too, that you're creating all these software programs and these apps for HVAC technicians on literally measuring all these things that no one does out in the field because it's so complicated and so complex. And now you've got this app, they download it, they put in a couple ports and boom, boom, boom. They've got all these high-tech measurements to be able to balance ductwork and, get the right airflow and fix these problems. And not only that, but you guys are I think you're moving in the direction that we're really going to need, which is focusing on training as well, right? Can you talk a little bit more about that?
Yeah. Gary tells this kind of funny story, well, sad and funny story, where he was like, yeah, we get the blower door figured out. It's like the mid 80s. We're selling a bunch of them. He's like, no, I'm selling blower doors. And he's like, I figured like the journey that he went on to learn how buildings worked and how to effectively seal them. He figured, okay, well, now we got this tool. Let's get it in the hands of builders. And, he's like, let's get like a decade worth of like pushing this with builders, and they're going to learn what I learned and get excited about it and then want to make better buildings. And he's like, and then, it's like, I thought we'd have it solved. And, now it's 3 decades later and we're still
not so much.
Right. And there's a lot of people who did kind of, get on board with what Gary and others were thinking at that time. And it pushed, we had some really interesting buildings that were built in the 80s. Code started changing in the 90s, but adoption is still an issue. I mean, this is in a lot of ways a code enforced thing. And so what some of yes, you can do these tests. We've been able to do them for decades now. Are they easy to do? Are they intuitive? There's like a level of refinement that I think we're focusing on now, because it doesn't need to be and shouldn't be a science experiment. That can be fun for a while, but not for an industry. An industry needs a process that is fast and easy. I did stuff in radon. There's a lot of different areas in building science where there was like the originators who figured it out and have a lot of passion. And then, you need that second wave and third wave of folks that refine it. And I think that's where our focus is now. So this, the apps that you're talking about, yeah, this needs to be, we need to make it as fast as possible so that it can be done quickly and integrated into a sales process or a building process, so that we can do more of this. Get this information out there and make it actionable. If things are good enough, great. Let's move on to something like where can we be very effective in this as we diagnose buildings. So an area of focus, and you've mentioned this, is we think with heat pumps and the adoption of heat pumps, specifically ducted heat pumps, that there's a lot to be done making sure that that's successful. Those can have a really positive impact for homeowners. And I think just climate wise, our grid in Minnesota is increasingly becoming greener and greener and greener. Like every time I turn my light on, the wind and solar resources that are thrown onto our grid is making that a better option over the long term. And so having our homes heated could be a really great thing. Heated with electricity. So heat pumps is something that we're trying to figure out, and we have a thing called a True Flow, which Tessa mentioned. And yeah, it's a device that you put wherever the filter is in your furnace system, whether it's a filter slot or if it's a central return that has a grill. And you turn the system on, and in about 5 minutes, we can figure out what the actual flow of that system is. If you've got natural gas or propane and a 80 or 90% efficient furnace, the kind of rule of thumb has worked pretty well. The airflow that you need to deliver the heat. With heat pumps, it's a lot. You need a lot more precision to know exactly, can we actually heat this house with a heat pump? And in Minnesota, we've got a cold climate here, but they've got these great newer air source heat pumps. We have to push, 3 tons, 3.5 tons sometimes to be able to heat our homes here. Can the ductwork handle that? If the ductwork was designed in the 50s, can we move, modern amounts of air through those ducts and have them not be a restriction? That's a big open question when it comes to the heat pumps. So we've got a device that, we've started to get into the hands of HVAC technicians that helps them answer that question. So they know up front, hey, if I'm going to talk to a homeowner and we're talking about swapping out a gas furnace for a heat pump, the sales point there is you need to know, do we need to do additional work on the duct system, or is this duct system good enough and we can just swap the box out? So that's kind of a new area of focus that we're leaning towards.
Something you just said, swapping out a gas furnace for a heat pump system.
Yeah.
I haven't heard a lot about that. Normally what I hear is we're going to swap out the traditional air conditioner with a heat pump system, but we're going to leave the forced air furnace there because there's just kind of an assumption that most people make that you're never going to be able to get enough heat out of a heat pump. What are your thoughts on that?
I mean, again, it depends. If you don't, you can absolutely do it. There's quite a few people that are doing it. It becomes more important to understand the load of your house. What is the actual heating and cooling load of this house? Can we pull that down? Can we lower the heating load of that house and get it to a point where it's low enough that we can then effectively use, in our climate, a cold climate heat pump to meet that need? So, I mean, people who are smarter than I am on heat pumps, I've heard them say quite often, yeah, when it comes to air conditioning, we should just be swapping out a current, older AC for a heat pump AC. That's kind of a no-brainer. It can be really beneficial if that heat pump can be sized appropriately to not only do your air conditioning but also do all your heating in the winter. So, yeah, I mean, are you guys seeing that in your line of work at all? Are heat pumps moving in? Are you seeing more of them?
I don't get in the field anymore, so
okay.
I don't know.
Well, and I would say a lot of the homeowners that I'm working with are in older homes, and they've got older heating cooling systems, and they're thinking about upgrading. But going back to this heat pump question, Reuben, it's interesting because I think after I graduated at the U of M, I was helping do some research with Building America. It was a DOE program, and one of the projects was heat pumps and how well they performed in cold climates. And the research was like, they're not so great up in Minnesota. But that was 10 plus years ago. I'm dating myself, more than 10 years ago now. And heat pumps have come a really long way. And you can get these cold climate heat pumps now that function and provide heat down to minus 20 degrees Fahrenheit. Yeah. So we're moving in that direction. And I think, give us another, few years, the technology is going to be even better. And we just need to I feel like we need to get the industry caught up with the engineering. We need to get the technicians and the HVAC people that work with these systems actually trained on how to properly size them and install them and get them into houses. And that's what I feel like that's what you're positioned to do. You've got this great facility that you can actually take these contractors and show them what to test, how to test, what questions to ask, which I don't know of anyone else that's doing that. Do you?
Not in the exact same way that we are. There's a lot of other good organizations that do the training, by itself. Distributors there's a couple of really great distributors of different HVAC systems that do really good training.
Sure.
And there's other
But from that
organizations.
whole house, like building science, holistic perspective, thinking about all these things and airflow and building envelope and the HVAC integrating with that, you guys are really unique in that way, I think. Yeah,
I could name a few that do similar stuff, but yeah, it's not super common. And I think it'll be interesting over the next, I'd say 5 years, as the rebates that were passed a few years ago at the federal level are now finally making their way to the states. And over the next year and a half, we'll see programs across the country pop up in each state that are offering pretty legitimate rebates, in the thousands and thousands of dollars for home energy retrofits, for air sealing and insulation, electrification, even upgrading panels. In Minnesota, they're going to be upgrading some of the electrical panels with the idea that, hey, we're over time probably going to move towards more electrification in homes. And the thing with heat pumps is this kind of nexus point is there's this new technology now that can heat and cool, and might be a good, carbon reduction option. Could be very cost neutral or cheaper than the current system, depending on what fuel you're on. But it likely, for older homes like the ones you're talking about, Tess, it'll likely require some amount of permanent load reduction in the house. So taking my 1950s house, which leaked as much as, we can build an apartment building now. Apparently that's as tight as my house. My house needs to be tighter than that. So that's where, using a blower door, using a duct plaster, I think that'll be very interesting when these rebates hit. That I think that'll be more present to homeowners, that money talks. So I think they'll hear about this, and the idea of having someone come into your home, do some of these things that Tess, I know you do, and help them understand how to prioritize. Window salesmen are doing a great job. Like, everyone asks about windows. Can I just get some new windows? Like, all my problems will be solved with tens of thousands of dollars of new windows. Yeah, windows have a role to play, but there are cheaper options that have a lot better bang for your buck to reduce the load on the house, the need for energy in the house. And if you can reduce it sufficiently, now these heat pumps are getting better in capacity. We're getting to a point where now we could reduce the load and put in these new systems and have a really good, upgraded, modern home.
Yeah, it's like this metaphor. I know I've said this on the podcast before, so forgive me. But it's like, think about driving down the road and it's cold outside, it's winter, and you've got all your windows down and you've got your heat turned all the way up, blasting, and you're freezing your butt off. You don't call the HVAC contractor to put in a bigger furnace or a bigger boiler or add more heat, right? You roll up the windows first. And so when we're thinking about, improving our energy efficiency, the first place to start is by tightening up the building envelope, reducing the heat loss, or reducing the demand on cooling if you're in a southern climate, by buttoning up that building envelope, making it more airtight, controlling the airflow, adding, more insulation in the areas that you can. That's cost effective, and really addressing that first. And then once you do that, then it's this chain reaction of all these other things you need to think about, like we've talked about, right? Mechanical ventilation, indoor air quality, HVAC, all these things. So I think it just becomes even more important that we have these conversations about how you can't just talk about updating like a heating system in a house anymore. You really should be thinking about all these other things holistically and how they integrate and how that will impact kind of your next step and the best step to take.
Yeah, and that's an interesting analogy. Think about comfort in that car. Like, yeah, okay, I could turn the heat up in this car more, and I'll be marginally more comfortable, but I'm never going to get rid of this draft from having the windows down. So yeah, step one, let's close the windows. Like, get control over the house, the inside versus outside. Once you have control, now you don't have to spend as much. That fan doesn't have to be up as loud, pushing as hard as it is. You can turn that way, way down. now you need to dehumidify, which, there's your building science next step on that analogy is now the windows can fog up. Okay, we need some airflow here.
Yeah.
But these are all now manageable things that don't cost a lot to do. Running a fan, not terribly expensive if you have a nice tight house. You can move air around that, you can circulate it. They become very, very comfortable. That's and also very quiet. Like Gary has a very nice house. 3 or 4 of the engineers here have done retrofits of older homes, and they say 2 things. Oh man, I can walk around barefoot in my house in the winter. It's not cold in my house anywhere, and it's very quiet. And so there's these kind of human comfort things that come out of it. There's the energy side of it and all that, but updated modern houses that are done well, air sealed and insulated well, they're very comfortable homes to live in.
Yeah. So I think it's fascinating that, our codes are kind of pushing builders to, start building houses that are more airtight, more insulated, to have better controlled ventilation systems that offer balanced ventilation or, exhaust point source ventilation, and also, heating cooling systems that are more efficient. And all of that comes back to just, okay, you can say these things, but how do we train the contractors to understand what that means and what tests to do? And when they're running into this comfort problem, how to fix it? And there are a lot of, innovative and really smart contractors out there that I think figure these things out as they go. But the Energy Conservatory is creating these apps and these tools and this training facility to help these contractors get ahead of the curve and do these things in the field. And so I think that's really cool. So when is the Energy Conservatory going to be offering trainings, and how would contractors find out about it? Is that even out there yet?
We're finishing up designs. Someone 2 offices over from me is working on CAD right now, or he should be. And so our training center is we hope to have up spring or summer of 2025. And there's going to be there's a lot of folks who I think we're going to use the facility to do trainings. We'll do some trainings there for selfish purposes, but we also have enough space that we want to offer it to other people in the area or around the country that want to provide trainings. So I don't have any dates, but it's coming within, I'd say, the next 6 months. We'll have a really nice facility here where we can do a lot of cool trainings.
Looking forward to that. And what's a good website for people to go to if they want to learn more?
Energyconservatory.com is our website. We have a training and applications tab on there. So for anybody who's actually doing the testing, we kind of have that broken down between residential, ducts and envelope, big buildings, because there's quite a few people, as you mentioned, testing larger buildings now, and then the HVAC side of it. Homeowners, I'd say that's probably not as great for homeowners, though they can learn quite a bit there, but that's more focused on the technicians themselves. But that'd be a good start there. And then we have dozens or hundreds now of really good training videos on our YouTube channel. So looking up the Energy Conservatory on YouTube is also a good option.
Cool.
Excellent.
Very cool.
Excellent.
Thank you, Jake, so much for coming on. And is there anything else you wanted to add or touch on that we didn't get to cover today?
I think that this is a really interesting time for building science. It's kind of been off a bit on its own a little bit. And I think over the last 10 years that I've been involved with it, I've seen a lot of adoption of some of these things that used to be very cutting edge sciencey things in the 80s being kind of streamlined. I think with the rebates that are coming and the way information now spreads, this is another example of that there's now another group of people getting interested in this sort of stuff that isn't just the scientists or the contractors, but I've been to some really cool homes that just a normal person is saying, I want to take an active role in either building my dream house or upgrading this house that I have, or I just bought this new house and I want to change it. So I think that the next 10 years are going to be super interesting because there's going to be this push-pull thing that happens in buildings in these markets where it won't just be someone, saying, hey, you need this new heat pump. There's people asking for it. There's people wanting to have a house that is efficient and cheaper to run. It's a fun time to be involved in something like this.
Yeah, very cool. Well, I'm excited to have you back. Maybe we'll do a follow-up to this and see where the Energy Conservatory is at, hear about any new technologies or apps or tools you guys have created and where you guys are at. Yeah, it'll be fun.
Once we have the training center up and running, you guys are definitely welcome to swing by and take a tour of it. It'll be a lot of fun. We've got some really cool things planned.
We might have to do a training day there. We did one at the Energy Conservatory many years ago, didn't we, Tess, for the Structure Tech employees?
Yeah, I'm trying to remember. Were we talking about HRVs and ERVs and balancing them?
We were, and checking on airflow through furnaces and pitot tubes and all kinds of fun stuff.
We nerded out.
A little lab in one of our training houses that'll specifically be ventilation measurement focused. So sweet. You guys should definitely swing by.
Cool.
Very cool. Thank you so much, Jake, for coming on.
Yeah, appreciate it. And for our listeners, if you got any questions, we'll have a link there to the Energy Conservatory. And if you have any questions for me or Tessa, any follow-up feedback, whatever, please email us or read them all at podcast@structuretech.com. And we'll catch you next time. Take care.